This is just a quick follow-up to one of the last videos I posted where we defined the eccentricity of our planet's orbit. If, like me, you have given your planet a near-circular, low-eccentricity orbit like what Earth and likely most habitable planets have, then you can ignore this video if you want. This is only important to planets with an orbital eccentricity of 0.1 or higher. In such a case, the large difference between your planet's minimum and maximum distance from its parent star will result in the amount of energy your planet receives from the star, its stellar irradiance, varying significantly throughout its orbit. This variance will affect your planet's seasonal temperature range and have major consequences to the planet's climate, so it might be a good idea to determine what its minimum and maximum stellar irradiance is. To calculate both of these parameters, we can use this equation, which relates the instantaneous stellar irradiance to the luminosity of the parent star divided by 4 pi times the orbital distance squared. When calculating the maximum stellar irradiance, we'll need to use the planet's periapsis distance, or shortest distance. And similarly, we'll use the planet's apoapsis distance, or farthest distance, to calculate its minimum stellar irradiance. The way I'm going to do this is start by entering my star's luminosity in parentheses. Then divide by 4 pi, also in parentheses. Then press equals. I've done this to add this part of the equation to the calculator's history. So now I can easily recall this number for the second equation and save myself some effort. When I have the number, all I have to do is divide it by the distance squared. So with it on the calculator screen, I'll divide and enter my periapsis distance. Then square it by raising it to the power of 2. So your equation should look something like this. Press equals, and there's my maximum stellar irradiance. So I'm going to add that to my SAP sheet, even though this particular planet doesn't really need it. For the minimum stellar irradiance, I'm going to click on my calculator's history button, select the number I saved earlier, and then divide it by my planet's apoapsis distance squared. Your equation should look something like this. Press equals, and I'll add that value to my SAP sheet as 1,193 watts per square meter. After adding the minimum and maximum stellar irradiance parameters to your SAP sheet, you will need to change the name of the original stellar irradiance parameter that we calculated previously to the mean stellar irradiance.